Welcome back to more excitement with Algebra 2. We're gonna kill him today! I'm sorry. How's it going, you guys? Mr. Pike again. Alright, so in this video, we're going to be talking about the absolute value stuff. Absolute value solving is what we're going to be doing today. I just want to remind you guys, I think you saw this in middle school. You saw it a little bit in Algebra 1 as well. No, you definitely saw it in Algebra 1. I know you saw it in Algebra 1. So this is just a review for most of you guys. But the absolute value, just a reminder, is the distance any number is from 0. So what I mean by that is if I am, there is 0, right? I'm marking 0. So if I am at 4 or I am at -4, the absolute value of 4, that's how it's denoted, is these absolute value things that you can kind of see right there. The absolute value of 4 is 4 because it's 4 units away from 0. The absolute value of -4 is also 4 because it's 1, 2, 3, 4 units away from 0. That's all that the absolute value is talking about. All right, so since I don't know, like here in part A, I want to know, to solve this, solve the words. Come on. The absolute value of x. How far? Okay, I'll try one more time, and then I'm going to rewind this and try again. All right, so the absolute value of x is 2. So that means that it has to be some number is 2 units away from 0. Well, I don't know which, right? So x could be 2, right? So then it's just the absolute value of 2 is 2. But x could also be -2, right? So if I put in either -2 or 2, they're both 2 units away from 0. That's all that 2 is talking about, what it's equal to. I need to be, the absolute value of this thing needs to be 2 units away from 0. Either one of these are good solutions. Both of those are options, right? So we're going to come out with 2 solutions on a lot of these. Not all of them. Well, actually, yeah, all of them. So just kind of know that as we're going forward. It could be the positive, it could be the negative. That's what an absolute value is. It's just the distance away from 0. Absolute value is distance away from 0. All right, so now moving on. Part B, the absolute value of x is -2. So here's another thing. The absolute value is only ever a positive number. It represents a positive distance away from something, right? So it doesn't go negative. Negative would be like inverting it, but it doesn't happen, right? So this one is actually just no solution. It's not even possible, right? So here's the one with one answer. It doesn't work. All right, so moving on now. Now we're getting some more stuff with it. So we have the absolute value of x plus 1 is equal to 4. So here's where this thing inside, this could be 4. That could also be -4. All right, such that if I had -4 right there, the absolute value of -4 is 4, so I know that would work. So this x plus 1 could be -4. This x plus 1 could also represent 4. So that means if I take both of these equations and I solve them, that's going to be both my solutions. So here I'm subtracting 1, such that x equals 3. There's one solution. And the other one, subtracting 1, x equals -5. There's my other solution. So there's my 2 solutions, right? So essentially, we're going to try to get the absolute value of whatever by itself first, and then we are going to set up the 2 equations and solve them. So looking at part D down here, I have absolute value of x minus 12 equals 15. So that means x minus 12 could equal 15. X minus 12 could also equal -15. Could be either way. I don't know which way. So I have to assume it could be either one. So in both ones, though, I'll do the same math and I'll add 12. All right, so here, x will equal 27. Over here, x equals -3. Those are both of my solutions for the problem. All right, if you don't believe me, you can even check it. 27 minus 12 is 15. The absolute value of 15 is 15. If I plug in -3, -3 minus 12 is -15. The absolute value of that is just 15. All right, moving on. We're getting a little bit more complex, but still, same exact idea. It's just going to be a little bit more tough to solve, but it's not that bad. It's really not. So if I take this, the absolute value is by itself. So 3x minus 5 equals 20, or 3x minus 5 equals negative 20. Right? Could be both of those options. And in the math, the cool thing about this is the math works the same both ways. So if I need to add 5 to solve for x, I do the same thing in all the equations. But you don't have to do them all at once. You can just focus on this one. So let's do that. 3x minus 5 equals 20. We'll need to add the 5 to the other side. Do that first before you divide by 3. Don't divide by 3, because then you'd have to divide the 5 by 3 and it gets ugly. So just make sure you add or subtract before you multiply or divide things to the other side. So now I have 3x equals 25. I can divide by 3 to get rid of that, and divide by 3. So now I have x equals 25 over 3. You could also write that as 8.33333333, repeating. It's either way. It makes no difference to me. Just pay attention to what Apex gives you, and that will be your solution. But I think they give it as fractions most of the time. Fractions are cool anyways. I like it better. So here I have negative 15, and then I'll divide by 3 to make that 1, and divide by 3. So x equals negative 5. There's my other solution. So again, 2 solutions.
Oh yeah, buddy. Oh yeah, big time.
Court left. You lazy bum. She went to sleep in another bed. I bet you $1 million bucks. Alright, so we have the absolute value by itself. 3 minus 7x equals 24. And 3 minus 7x equals negative 24. So those are both my equations set up. So now, again, you can focus on one. You can do both same time. Makes no difference to me. I'll focus on one to help you out. So if I subtract 3, now pay attention. Don't forget about that negative sign in front of that 7x. It's still there. So I have negative 7x equals 21. And then I can divide by that negative 7. Divide by negative 7. X equals negative 3. There's one solution. Work out the other side. Do the same math. So minus 3, minus 3. And again, don't forget that negative 7 is still there. Keep the signs in front of everything that you have. So negative 27. So I can divide by negative 7, divide by negative 7. X equals 27 over 7, which does not reduce. Let's see, that would be, oh no, oh no, 3.85, something like that. I don't know. That's pretty close. 2707 is plenty fun. All right, so now we're getting into ones where we have something outside of the absolute value. So I can remember how I was saying we want the absolute value by itself. That's our first goal, to get the absolute value by itself. Well, this absolute value is being multiplied by 2. So how about I just divide by 2 such that now the absolute value is by itself. And then I can do exactly what we were doing in the past 1, 2, 3, 4, 5, 6. So I can say x equals 4 or x equals negative 4. Hey, there's my solutions. I'm done. I didn't even have to solve anything on that one. So now here's where it gets fun with part H. Yeah! There's my absolute value, right? The absolute value is 6x minus 5. I need to get that by itself first. So we're being multiplied by 3, and we're adding 7 to that absolute value. So again, add or subtract before you multiply divide. So I would subtract this 7 first, such that I have 3 absolute value 6x minus 5 equals 38, right? So now to get rid of that 3 that's multiplying, I'm going to divide by 3 and divide by 3 on both sides. All right, so now I have absolute value 6x minus 5 equals 16. Now the absolute value is by itself, so now I can continue solving this thing. I'm going to get some other blank paper somewhere. I'll use the next lesson. No, I won't. That's not a good idea. Hang on.
Give me just a minute.
All right, sorry. I don't know why I do the lowest voice so much. Anyways, absolute value is by itself, so I can take that 6x minus 5 and say 6x minus 5 equals 16, or 6x minus 5 equals negative 16. And then just solve both of those equations. All right, so in both of them, I'm going to need to add 5, so plus 5 makes it go on that side. And then I'll get to 6x equals 21. Then I can divide by 6, so that makes 1. So x equals 21 over 6, which will reduce, so make sure you guys go ahead and reduce it. All right, so we can divide both of these by 3, so that will be x equals 7 over 2. Yes, that's right. All right, so then on this other one, I'm going to need to add 5 and add 5. So again, that 5 goes there, so I have 6x equals negative 11. This side will not reduce when I divide by 6. So x could also be negative 11 over 6. So those are both of our solutions. All right, moving on. Solve the following absolute value inequalities. So now here's where this gets a little bit tricky. So my trick is to flip both signs. I'll show you what that means. So if I have the absolute value of x is less than 6, remember that's saying the distance here has to be less than 6. So if I were to draw it on a number line, right, here's 0, here is 6, and here is negative 6. I cannot be equal to that distance of 6, so I would have like open circle, right? And the distance has to be less than 6, so I need to be somewhere less than 6 units away, right? So that means if I were at 2, 2 is less than 6. If I were at negative 3 is less than 6 units away, right? So I'm going to be somewhere in the middle of those. So my solution for this one is actually going to be everything from negative 6 to 6. That's how we will write our solution. All right, so what I meant when I said change both things, because if I read this, kind of helping myself with the number line, this is x is less than 6 and x is greater than negative 6. So notice here, x is less than 6. On this one, right, I have my inequality or absolute value of x, and then I have the inequality and I have the 6. Notice how the inequality changed directions and the sign on the 6 also changed. So that's what I mean when I say change both signs. This will always help you with solving inequalities because I change the signs, so change that sign and change that sign such that I can solve my equation. All right, so x was less than 6, so I can see it going less than 6. It was greater than negative 6, so greater than negative 6. So it's going that direction. So since they are going towards each other, it's the parts in the middle of those. All right, it's both of those things together. So we would say this is our solution. This is the part that I'm really going to be looking for. That's what Apex is looking for. This is a solution right there. All right, so part B, moving on. I'll leave this up there while we're working on this one. So absolute value of x is greater than 6. Let's do our trick. So let's say x is greater than 6, and x is, switch the sign, less than or equal to negative 6. So what that means, if I were to draw it on a number line, here is 6, here is negative 6, so I'm greater than 6, so I'm somewhere there, and I'm less than negative 6, so we are somewhere out there. So what this means is it looks like I'm going from everywhere from negative infinity all the way up to negative 6, and from 6 to infinity. My solutions can be anywhere in there. Remember, this is the solution that we're going to be looking for. Remember that U just means union, which is here or here. So does that make sense? X is greater than 6, so I needed my distance to be 6 or more units away. So there's where the distance is more than 6 units away. There's where the distance is more than 6 units away. So yeah, I think our little trick works. So switch both signs when you're solving inequalities, and it'll help you out. I would also highly suggest you guys draw this so that you can come up with the solutions a lot faster. You don't have to think as much. All right, moving on. So here I have the inequality by itself, or sorry, not the inequality, the absolute value by itself. So I can go ahead and write out both equations. So x minus 4 less than or equal to 9, keep it the same, and then switch both. So x minus 4 greater than or equal to negative 9. And then I'm going to solve both of these equations. So plus 4 plus 4 plus 4 plus 4. So x is less than or equal to, haha, that is not right. Oy vey. So less than or equal to 13, and x is greater than or equal to negative 5. So if I put this on a number line, I have negative 5, and I'm greater than or equal to, and I have 13, which I am less than or equal to, so it's everything between. So what that means for our solution is that I want everything from negative 5 to 13, where they are both included. All right, so both included, meaning that I needed to put brackets around them. Anytime you're going to have this or equal to part, we're going to have to put brackets around our solutions. All right, moving on. Doing good. We only have a few more. Sorry, this is a little bit longer one, but I just want to make sure that I help you guys out as much as I possibly can. If you feel like you have a good grasp on it, you're always more than welcome to stop the video. You're not required to watch all of the video. All right, so here, absolute value is by itself. So 3x plus 4 greater than or equal to 13, and 3x plus 4 less than or equal to negative 13. All right, solve both of these. So minus 4, 3x greater than or equal to 9, divided by 3, so x is greater than or equal to 3. The other one, minus 4, 3x less than or equal to negative 17, so x is less than or equal to negative 17 over 3. All right, so there's both of our solutions. So we are greater than 3. So if I put this on a number line, there's 3. Here is negative 17 over 3. I don't need to know exactly where it is, just kind of an approximation. So if I'm greater than 3, I'm going that direction. Less than or equal to negative 17 over 3, so that direction. So it looks like they're going away from each other. So to include both, I need to say negative infinity to negative 17 thirds. That should be a bracket. Just told you before I started this problem, that should be a bracket. And bracket 3 to infinity. That's why you don't do math in pen, because you could find it easily. This frustrates me in my own work. All right, so that's the solution I'm looking for in interval notation. Fast now! Oh! I really promise I'm a pleasant person. I don't ever throw things at anybody. Unless you're coming at me, bro. Or is that still a saying? I don't know. Give it a few years and it's going to be worse. All right, so we have, notice here, we are multiplying our absolute value by 4. So I need to divide by 4. That's the very first thing I need to do. So 2x minus 12 less than or equal to 4. So notice that is dividing by 4 and dividing by 4. All right, so now my absolute value is by itself. So I can say, let me do it in blue. Whoa, I like blue. 2x minus 12 greater than or equal to negative 4. Make sure you change both signs on those. All right, so now I'll solve both of those for x. So I'll need to add 12 plus 12 plus 12. That was a 2. 2x less than or equal to 16. Divide by 2. X is less than or equal to 8. Plus 12 plus 12. 2x greater than or equal to 8. So x greater than or equal to 4 when you divide by the 2. All right, so now I would put these on a number line again, as always. Come on, I need to write, pen. You need to be out and ready. Ready to go. All right, so I have 4, and I'm greater than or equal to 4, so I'm going that way with the 4. I have 8. I'm less than or equal to the 8, so I'm going that way with the 8. So since they're going towards each other, I need to include the things in between them. So I have from 4 to 8, and that would be my solution set. Green kind of sucks. I'm not going to use green anymore. That's kind of hard to see, at least for me. Maybe it's because I'm old. I don't know, man. I don't have any teeth anymore. You young whippersnappers. I'm sorry. So sorry. So sorry. All right. So here, first thing you're looking for is the absolute value by itself. There's not in this one. So I need to subtract the 12 before I do anything else. So I have 5, absolute value x minus 9 is greater than 7. And then I'll divide by the 5. So this will be ugly numbers, but it's all good. It's all good. It's all good to hurt me. So I have absolute value x minus 9 is greater than 7 over 5. All right, so it's going to be ugly, but it's not a big deal. It's really no problems. So if you want, change this to 1.4. That's fine. It's still going to work the exact same way. Right? So I have x minus 9, keep it all the same, greater than 7/5, and x minus 9, change and change. All right, so now I can add the 9 to the other side. So x equals, let's see, 9 times 5 is 45, plus 7 is 52 over 5. And now 9 times 5 is still 45, minus 7 is 38. All right, so again, you can put those as decimals if you want. With that 52 over 5, you should have 10.4. With the 38 over 5, that should be 7.6. Makes no difference to me either way you want to do it. So here I have 52 over 5 out there, 38 over 5 there, not equal to either one, so I have open circles. Less than 38 over 5, so I'm going that way. Greater than 52 over 5, so I'm going that way. So it looks like I have everything from negative infinity to 38 over 5, and from 52 over 5 to infinity. Did I write off the paper? I didn't. Yes, yes, great success. I was so worried. All right, so that would be your solution set. So again, you can put decimals if you want. I don't like them, but you can if you want to. All right, last one. Finalmente! Hey, hey, yeah, yeah. I'm sorry, I get in trouble for being loud sometimes. I hope that wasn't too loud. I'll start talking softer. I'll try to remember. My wife gets so mad at me whenever I just make noises sometimes. All right. Anyways, you don't care. You don't care. All right, so get the absolute value by itself first. So I'm going to add 8. So absolute value 6x minus 7 is less than 28. And then I can get the absolute value is by itself now, so I can get both of my equations. So I have 6x minus 7. Keep the sign, keep the sign. 6x minus 7, change the sign, change the sign. All right. Now add the 7. 6x less than 35, and then you can divide by 6. It will reduce. What will it reduce to? No, it doesn't. Look at that. It has to be 35 over 6. All right, and then this one, add the 7, add the 7. So 6x greater than negative 21, and x is greater than negative 21 over 6. That one will reduce though, because they're both divisible by 3. So 7 over 2, we already did that one. All right, so then draw a number line. So I'm greater than negative 7 over 2, not equal to, so open circle, and less than 35 over 6. So open circle there as well. So I'm in the middle of this. So I'm greater than that, less than that, so in between both of them. All right, so it looks like I'm going from negative 7 over 2 to 35 over 6, and there is my solution points. Not points, set. Solution set, it's going from negative 7 over 2 to 35 over 6, everything in between. All right, something just to remind you guys, we talked about it in the first unit, but don't forget, if you have an inequality and you are dividing or multiplying by a negative number, right, so here I'd have to divide by negative 2, I need to change the direction of that sign. It's really just a shortcut. So x would be greater than negative 2. That would be part of your solution set. So don't forget about that trick. Here's why the trick works real fast, and then I'll shut up. I know this is a long one, I'm sorry. But if we take the long way and we add 2x, and we subtract 4 from both sides, this will be negative 4 less than 2x, and then I can divide by the 2, so negative 2 less than x. So look, x is greater than negative 2, x is greater than negative 2. This change the sign thing is just a shortcut for doing it the long drawn out way. All right, I'll shut up. Thank you guys for watching. As always, please, please, please let me know what I can do to help you guys. I'm here for you. All right. Boop.